I'm going to introduce the first speaker. It is Linda. She shares her time between the Institute of Environmental Medicine at Karolinska Institute, Department of Philosophy and History at the Royal Institute of Technology. And her main line of research is identification, assessment, and management of hazardous substances. However, she also collaborates with science education researchers on the topic of how to include risk and risk assessment in upper secondary school science. So I will very much welcome Linda Schenk.
Thank you for inviting me here to share my experiences from being part of a project that focuses on teaching risk concepts in pre-university education. Basically, why I'm invited is because my involvement in this Risk Edu project, that we call it. I started working together with one of these researchers in science education, Margareta, already 10 years ago, when we looked into teaching about nanomaterials and nanotechnology in physics and risks with nanomaterials. And then Karim contacted Margareta because he was contacted by a radiation biologist who wanted to involve himself a bit more in teaching about risk in upper secondary school. And that was basically how Risk Edu was born. So in the project, which was multidisciplinary, we were a team of science education researchers, Karim, Jan, and Margareta, two upper secondary school science teachers, which are Karin and Lena, and then two, let's say, risk experts, Andrzej, the radiation biologist, and myself. And yeah, the project ends this year, and we've been going on since 2015. And our focus has been, in the first round, to investigate how teachers can support the development of scientific literacy through teaching about risk and risk assessment. And I will get back to scientific literacy in a bit. And also, towards the end of the project, we worked more towards developing didactic models for including risk and risk assessment in science teaching. And didactic models are conceptual tools for teachers to plan, execute, and evaluate teaching. So some of the questions that we have been working with in the Risk Edu project, we've been targeting many different subject areas, but for instance, in physics, we've been targeting non-ionizing and ionizing radiation, climate modeling, and in biology, genetics, molecular biology, and health and disease in medicine. So we have experience from quite broad range of topics. But I also want to point out that the idea to teach about risk is not something new and not something that we came up with. The first example that I know of in the scientific literature is from 1975, when Robin House pointed out that radiation risks would be an interesting topic to teach about in science education. In the 80s, Harry Eichelhoff and colleagues actually developed and implemented a teaching sequence on ionizing radiation and the concept of acceptable risk. And a few years later, we have this letter to the editor from Glenn Briscoe in Risk Analysis, pointing out that we need to educate our future citizens about risk and risk concepts. And very interesting is this encouragement to all risk practitioners to volunteer their services to local school boards to help introduce risk concepts into public education, which is basically the same conclusion as I will come to today. So what I will talk most about today is teaching under the umbrella of socio-scientific issues, but there are also papers that specifically address risk literacy or risk education. So I'll start with a short comment on that. The papers targeting, or the work targeting risk literacy, has a focus on numeracy, on understanding statistics and probabilities. And the literature I'm familiar with largely targets physicians' and patients' understanding of diagnostic tests, disease risks, etc. And there are a handful of publications that specifically target risk literacy in pre-university education. When it comes to risk education, that term or phrase is used a bit differently between publications. Mostly I've encountered it in works that target disaster preparedness, such as what should school kids do in case of a severe earthquake, and how to mitigate the hazards of, for instance, earthquakes. But also some works actually focus on education about risk and risk assessment. And I've given some examples at the bottom of references that talk about teaching risk. So, but as I said, what I will talk most about today is this thing called socio-scientific issues and how risk comes into play there. And I thought I'd start with a little bit of a background on science education and socio-scientific issues to set the context of my talk before I present a review that me and my colleagues did on risk in SSI. And then I'll finish with some reflections on risk in socio-scientific issues in science education. So basically the background both to teaching with socio-scientific issues or teaching risk literacy or about risk is that our educational system has to prepare students to become citizens in an increasingly complex world, and many situations we encounter in our daily lives require us to act on uncertain or incomplete knowledge. And one skill set that we want our citizenship to have is scientific literacy. And to define that, I put the OECD PISA description on the slide. And so basically, scientific literacy refers to the content knowledge in the scientific fields, but also to understand how that knowledge is derived, the role of nature of science and scientific methods, as well as then a willingness to engage in deliberation and decision-making using that knowledge, both content knowledge and knowledge about science as a process. In this report from 2015 to the European Commission, we also have a pointing out of the fact that our future citizens need more than just the content knowledge from science education, where we need a lot of different skills, for instance, critical thinking, and in this particular excerpt, also assessing risks. So outlining that, the skills we need is not only the facts that the science education gives us, but we also have to have additional competencies to solve these challenges we stand in front of. So how do we then try to foster scientific literacy in science education? And one way that has been used and is quite established by now is to teach with socio-scientific issues, or SSIs for short. And I'll borrow an overview of SSIs from Mary Ratcliffe and Marcus Grace. And as they point out, socio-scientific issues are current issues that may impact society and or our lives. They have a basis in scientific knowledge and often at the frontier. They involve forming opinions and personal or societal decision-making. And they deal with incomplete or conflicting reports or evidence bases, which in turn then may lead to these issues having a media attention framed by conflicts of interests. They may also involve cost-benefit analysis and risk interacting with values. So this idea of SSI being connected to risk is not something I'm the first to pointing out either. They may connect to sustainable development, and they do involve values and ethical reasoning. So teachers, they use social scientific issues to put the science in a societal or everyday context and make it relevant for the students. It has been shown that teaching with SSIs can promote growth and critical thinking skills. And it's also useful to teach about the nature of scientific knowledge and the nature of science as practice. And the figure at the bottom, I just put there to show that teaching about SSI has been present in the scientific literature for quite some while, but maybe that it took off some roughly 10 years ago, although it's not a super big field yet. As you see, we have roughly 100 publications per year in Web of Science. So, but what me and my colleagues wanted to do was to look at this body of literature on socio-scientific issues in science education and investigate how risk comes into play in them, because there obviously is a potential connection. So the aim of our review was to look at which topics are covered in SSI teaching, and would these lend themselves to also teaching about risk more explicitly, and to what extent is risk actually raised in these publications. So we did a scoping review using Web of Science and a very simple search string, and we found some 400 papers, which we read and categorized first according to whether they were empirical, that is presenting primary data, experiences from the classroom, for instance, or if they were of a more theoretical or review kind of nature. And then there were a couple that we decided were not actually SSI papers as well. So we found about 300 empirical papers and a little bit less than 100 of these more review type publications. Furthermore, we read through the empirical publications to identify which SSI topics were treated. And we also looked at the treatment of risk in these papers. So to give you some examples of what an SSI topic could be, as already pointed out in my first examples from Robin House and Harry Eichelhoff, nuclear radiation, nuclear power plants is one topic where this field kind of started, and still we do have some publications on that issue, meaning that we do have some teaching efforts on that topic as well. Gene modification techniques, of course, inspires a lot of socio-scientific issues, both in food applications or medical applications. We have nature conservation issues, such as pesticide use, or plastic pollution, and alternative energy sources or non-alternative energy sources with or without a direct connection to climate change mitigation. So we took all these topics and categorized them into themes. And here I listed those overarching themes from the empirical publications, and the bars represent how many times we found them. Those that have a visual sense for numbers see that this is more than 300, and actually, yes, one publication may describe more than one teaching sequence and thus cover more than one SSI topic. As we see, nature conservation, biotechnology, and climate change are the most common in terms of numbers. At the bottom, we also have a quite large bar that says general about SSI. And that one is mostly papers that investigate the attitude and opinion among active teachers on their opinions on teaching with SSIs. And our conclusion here is that these themes actually would lend themselves very well to teaching about risk. In most cases, these are also topics that we do risk assessment in, or risk perception studies. So no hindrance in terms of what kind of topics these SSIs concern. We also looked at the ages these SSI teaching sequences or empirical investigations targeted. And as you see, it's all over the full span from primary school to university level, and also in-service teachers in some cases. But most commonly it is in upper secondary school or high school that we implement this kind of teaching. But what we also find is that risk is not very frequently discussed in these publications. We just counted the number of times the word risk occurred in the main body of the text. So not in the reference list, and not if it was like a part of a word like asterisk. We did check for that. And almost half of the papers don't mention risk at all, despite being these topics that I just showed you. And another roughly third of the papers mention it a handful of times. So really, this is a very simple analysis, but I think it clearly shows that papers don't engage much with the concept of risk. Here I put the same data in a different shape. So you have the number of times risk is encountered in the main text on the y-axis and the year of publication of the empirical paper on the x-axis. And maybe there's a bit of a tendency of risk being more frequently treated the more recent the paper is. But I also highlighted 3 of the dots, and they represent the 1% of papers that actually define risk among these 300, or at least point out that there are many ways to describe risk, and so kind of position themselves to a description of risk. Another handful of papers also mention this discrepancy between experts' risk assessment and lay people's risk perception, but they don't really go into more detail than just the risk perception gap. And 2 of the papers actually also empirically investigate how students perceive risk or think about risk in their investigation of students' analysis of the decision-making process. So our conclusions from this review is that few socioscientific science publications engage with the concept of risk. Like half of the papers mention risk, and very, very few define their take on risk as a concept, or which description of risk they would prefer to work with in the specific issue. And the role of risk understanding and risk judgment in SSI discussions and decision making is still largely unexplored in this body of literature. And we would say that that is quite striking, as these socioscientific issues generally connected to risk decisions and would very well have lent themselves to a more detailed treatment of risk. So I'm gonna end up with some reflections on risk in SSI teaching, based both on some literature on the topic, but also on some of the experiences I've had in the RISK-EDU project. So one challenge that is mentioned is this plurality of definitions, or as many of us perhaps would prefer, descriptions of risk. And in some cases, there is this perception that risk has to be a quantitative concept involving the probabilities, and that can be very challenging to bring up in the classroom of your topic, so to speak. I have some anecdotal evidence or stories from teachers saying that despite working with probabilities in upper secondary school mathematics, the same students, when they come to the biology classroom, have a very difficult time transferring that knowledge into the biology teaching, for instance. There is also some stories about risk being perceived as very negative. And of course, it is connecting to adverse outcomes and things we do not want to take place. But then teachers can perceive that as working with that in the classroom scares or creates hopelessness among students. Teachers can perceive that they have a lack of knowledge, or maybe they have a lack of confidence in their knowledge. And of course, when we do talk about risk issues, many of them are multidisciplinary issues and connect to topics outside of the content knowledge of the particular classroom. So even if you have a radiation risk, you would connect to sociology, law, and those kind of topics that might be outside of the comfort zone of the teacher. And also when we work with issues that are really at the front of science, it might be very difficult for non-experts to assess what is reliable knowledge or what is study framed by bias. Teachers have also reported that they fear losing focus on the actual content knowledge when they bring in these issues that require us to discuss values or ethical standpoints. They require teachers to deal with uncertain knowledge and also to engage with the role of science in social context and both the power and limitations of science in society. And these latter 2 points especially require teachers to change from a more authoritarian to a non-authoritarian pedagogy. It's no longer that we can deliver this corpus, this body of knowledge that is certain, but we have a body of knowledge that actually might be changing and develop over time, which can pose some challenges if you are used to delivering the certain knowledge in a sage on the stage kind of way. Of course, there are also time constraints for our teachers, lack of support from colleagues, etc. But actually what I want to say here is also that many of these issues are not risk specific. They actually concern general teaching about socio-scientific issues as well. because the socio-scientific issues also are multidisciplinary, also are at the front of the knowledge development, and also by design require us to engage with the power and limitation of science in social context. So, some of my thoughts and reflections on what we as risk researchers can offer. First, I just want to point out that many of these issues need to be addressed at the workplaces, such as time constraints or lack of support from colleagues, or within the science education community. But what we actually can do is that we can offer continuing education on risk topics, certain frontier issues in risk analysis, or the method of risk analysis, risk assessment, risk management, the terminology and the definitions available, and the distinction between the definition of risk and ways to describe risk. I think that would be a very valuable lesson and topic. One thing that we in the RISK-EDU project have worked with is this didactic model of the risk concept, where we mapped 7 key concepts as we identify them in the literature. And I put them in relation to each other to indicate how they are related. And as I said earlier, a didactic model is a tool for teachers to plan or structure their teaching, but also to analyze it while it's ongoing or analyze it in retrospect. Also, as you see in this model, I've actually put probability and uncertainty in there at the same time. So I just want to point out that this is a didactic model and not a model supposed to be a representation of the definition of risk. It just points towards elements that can be important to raise in teaching. I also think that risk researchers are valuable partners in designing the teaching sequences, such as we have done in the RISK-EDU project. Risk researchers can help identify authentic examples, which is considered very valuable to actually put the science in real life context and show the students how the knowledge is actually used for societal or personal decision making. We can help with evaluating the knowledge sources because hopefully we are closer to the research frontier and we know the surrounding issues, so we can point out methodological issues or biases. But also we can be a partner together with the teachers in simplifying and adapting those examples and knowledge sources we helped identify to fit into the classroom. Because that's one point I really want to emphasize. And it is that it's important to collaborate with teachers because they know what works in the classroom and they know what would be an appropriate level. And even if I've been in this project for 7 years together with upper secondary school teachers and science education researchers, when I propose something, it quite often ends up with them telling me, no, it has to be simplified, or could we put it like this instead? So we really need that experience to make our experience relevant. So to give you some inspiration, I thought I put up the results from a Menti we did with some 40 teachers here in Sweden. Earlier this year, we had a dissemination conference in the RISK-EDU project. And we asked them to just submit topics that they thought would be interesting risk-related socio-scientific issues to implement in their classroom. I'm a bit surprised that COVID-19 and vaccines don't get even larger fonts, but maybe we were all just very tired of the pandemic at the time. This was in June, and we had to postpone the conference a couple of times, as well as in the end change it to an online solution, despite really having wanted to meet in person. But as you see, antibiotic resistance, climate, PFAS, an interesting topic for a toxicologist, and energy production are among the main issues here they would like to work with. So some conclusions from me is that we in the RISKEDU project and many others with us argue that knowledge about risk and risk analysis is valuable to socio-scientific issue teaching, because it can be a tool to structure students' discussions and deliberations, and also to structure their decision-making. And of course, knowing about risk analysis, risk assessment, risk management is knowledge that actually is important to us in our daily lives as citizens. So it would foster skills central to the education of our future citizens. So I argue that risk should have a more central role in SSI teaching. And I really think that this would be an interesting opportunity for risk researchers and science educators to collaborate, because we can together create teaching about authentic risk cases at an appropriate level for the students. So the review, the scoping review I presented to you is forthcoming in risk analysis, and you'll find it online if you want to read more about this topic. I also want to plug 2 other papers from the project. The one to the left, we described the RISKEDU project in a little bit more detail and give some examples of SSIs, risk-related SSIs that we have worked with connected to radiation. And to the right, I have put the review of the risk concept and the development of our didactic model of the risk concept. And before I open up for questions, I'd like to thank the students and teachers that have participated in the RISKEDU project, of course, my colleagues, and also the funding agencies that made all of this possible. And by that, I thank you and hope we can have some discussion before you move into the discussion sessions.
Fantastic. Thank you, Linda, very much.